Okay, we're just gonna go ahead and completely skip this page. Don't even worry about it. It is somewhat helpful, but we just don't have time for it. And unless you're gonna go on to pre-cal, which you might, which is totally fine. We go over this in detail in pre-cal, so I'm not really worried about that one. Summary, point float form, and it has what everything means. And then it also talks about slope intercept form and standard form, which we're eventually going to get to. But slope intercept form is the form that we actually use. You probably used the most last year. Y equals mx plus b, where m is your slope and b is your y-intercept. And then standard form, ax plus by equals c, that's just where your x and y are all on the same side and they're whole numbers. We don't get it into standard form very often, but we do have standard form and have to like make it look different. But there's three types of formulas: point slope, slope intercept, and standard. So knowing those is important. Okay, lesson 10, parallel lines. I'm gonna kind of follow what your book does, but I'm also gonna kind of go off and do my own thing, and the same thing with the parallel lines. So, I mean, perpendicular lines. Okay, so what parallel lines are lines that never touch each other. If you go on an infinitely, they are never going to touch each other. So, what ends up happening is they all have the same slope. If they have the same slope, that means that they are parallel. So I'm kind of going to skip this first part. And the main thing I want you to write here is that parallel lines have the same slope. So if I have a line and I just kind of move it around the graph, then all of the new lines are going to be parallel to each other. So like if I have this graph and this line right here, if I take that line and I move it down here, like the exact same line, I know it's going to look different, then they're going to be parallel because I didn't change the slant of the line, I just moved it down. So basically parallel lines are just translations of each other. But the point is they have the same slope. Let's see. Ignore that. Okay, so this page, again, I'm going to kind of go off on my own thing here. Ignore this. We're going to do like number one, and then I'm going to actually add some problems. So it says write the equation of a parallel line to y equals 2x plus 3 passing through the point -4, 1. Okay, here's what we're doing here. We are creating an entirely new equation, new line. What I'm using this equation for is they're saying my new line, my brand new line is parallel to that one, okay? And my new line goes through the point -4, 1. So let's start with the equation they gave me. If my new line is parallel to this one, then I know they have the same slope. And since my slope of this line is 2, the new line is also going to have a slope of 2. Okay, and then it says it passes through the point -4, 1. Okay, so I'm going to show you two ways to write this if I want to write it in point slope form, which remember is y minus k equals m times x minus h. Then my equation would be y minus 1 is equal to 2 times x minus -4, which would give me an x plus 4. So this is one option. I could stop here. This could be my slope intercept or my point slope form. But in case you get a problem that asks for point or slope intercept form, which is y equals mx plus b, I'm going to show you how to do that. Okay, so y equals mx plus b. The way we write that is like this one, where we fill in the slope and we fill in the y-intercept. So the way I figure out this one is I plug in my slope, and then I actually plug in my x and my y to x and y to help me find b. So let's see, y is 1, so b1 is equal to the slope, which we said was 2, times x, which if I look at the point is -4, and that's plus b, because I'm trying to find b. This becomes 1 is equal to -8 plus b. Add 8 to both sides, I get 9 is equal to b. So my equation is y equals 2x plus 9. Okay, so those are my two equations. It depends on what they ask you. If they ask for both, give them both. If they ask for one, give them the easiest one. Yeah, either one. Okay, we're gonna do both though. So I'm actually gonna add a problem down here. And I'm not gonna write everything that they wrote, but the equation I give you, it's gonna be the equation that I'm parallel to, and the point that I give you is the point that it passes through. So I'm mimicking the way they write this right here. I'm mimicking this, where I'm giving you the equation and the point. So it's parallel to y equals 3x plus 5, and it passes through the point 0, 2. Okay, so if I'm parallel, then that means my slope is the same. My slope of this one is 3, so my slope is 3. And then I have the point 0, 2. So this would be y minus 2 is equal to 3 times x minus 0, but x minus 0 is just x. So that's the point slope form. Slope intercept form, I need the slope, which I have, and the y-intercept, which I actually have. This right here is the y-intercept. So slope-intercept form would be y equals 3x plus 2. So those are my two answers there. I want to write the equation of the line that is parallel to y equals -1/2 x plus 1 and goes through the point 3, 0. Okay, so if I'm parallel to it, remember, I have the same slope, and then I have a point here. So y minus 0 is just y equals -1/2 times x minus 3. There you go. There's one of mine right there. And then if I want this in slope-intercept form, let's plug in our point. This is going to be 0 is equal to -3/2 plus b. I'm going to add 3/2. So 3/2 is b. So my slope-intercept form is y equals -1/2 x plus 3/2. So again, being able to do both is important because we do work a lot with slope-intercept form. Okay, last one. I'm gonna do this kind of down at the bottom because I'm running out of room. So I want the equation of the line that is parallel to 3x minus 7 and it goes through the point 4, 15. So my slope would be 3, right? It's parallel. So I could do y minus 15 is equal to 3 times x minus 4. There's my point slope form. Y-intercept form, I need to figure out these y-intercept. So plug in your x and your y. This is going to be 15. So when I say plug in, I don't know if I told you this. I'm plugging it into y equals mx plus b. I don't know if I actually verbalized that. So 15 is equal to m, which is 3, times x, which is 4, plus b. So 15 equals 12 plus b. When I subtract 12, I get 3 equals b. So the parallel equation of the line in slope intercept form is y equals 3x plus 3. So there is point slope form, and there is slope intercept form. Okay, so this is parallel lines. And then I'm kind of going to do the same thing with perpendicular lines. I'm not actually going to follow the notes. I'm going to kind of just do my own thing and use the notes as like my paper, if that makes sense.